Hi, I'm here today with Nelson from Broder Electric, and he's an electrician who's been helping us out here in the shop, wiring up all our equipment and outlets along the walls and all that. So we thought it would be interesting to meet with Nelson and see just how our electric circuits here are working, how all this stuff connects together. We have the main power coming in here somewhere.
Well,
right?
The main power coming in, it comes in this PVC pipe from outside.
Yeah.
To that junction box into this first disconnect. That is the main power. You turn this off, it will shut everything off that you have.
And that's like 600 volts?
600 volts at 100 amps. It sounds small when you consider that a house service can be 100 amps, but at 600 volts, this can power a lot.
And it's three-phase power?
Three-phase power.
So
out of that three-phase, you got your rooftop units that are fed off of it too. This is 600.
Is main power coming in.
Coming through the meter.
This thing is distributing it into these. Okay.
That's what it's called, the splitter. It distributes to different areas. This is the transformer, the disconnect that feeds the transformer, and that's where the 208 120 volt power comes for your general use in the building. And that's for your compressor, obviously.
So we bought a 575 volt compressor.
Yeah.
Which
is fed directly from this disconnect out of the splitter because it requires that 600 volts.
And it was interesting, it's a 5 horsepower motor, but it's a 5 amp circuit, 5 amp that thing draws.
The minimum wiring that we have in fuses is 15 amps, so it's protected at 15 amps, but it's very minimal draw compared to what you'd get.
When you consider it's an enormous compressor with a 5 horsepower motor, but it's only drawing 5 amps because the voltage is so much higher.
Exactly, but the compressor that was there originally from the shop that was here before you was actually about the same size, but it was a 60 amp compressor running on 208 instead of 600.
Okay.
So the motor was drawing a lot more amperage.
So the rest of the power for the shop comes through this disconnect up here into this big transformer.
Yes.
And that is converting the three-phase 600 volts
to three-phase 208. Because in a commercial situation, instead of 240, you're going to have 208 volts. Yeah. Most equipment will run without
so that's what we've been finding. So all the equipment we have here is home use, like 240 volt or 230, but it all runs just fine on
and you're looking at the equipment that you have. Technically, it was all designed to be used commercially. So while it's small, it works well on 208.
So this panel is nice and big, and you guys had installed this previously.
Yes.
But it was mostly empty. Like we had just a couple of circuits in here. Now we're filled it all the way up.
And that's why when you install a new panel, you try to go with the biggest tub that you can fill for the area that you have for future expansion.
And then a home panel would be two-phase.
Yeah.
So you have one outlet and another, and then they go in pairs.
Yeah.
So to get your 240, you would take a pair, and then one circuit breaker would go in there, and you have your things coming out of it.
Be a double pole circuit breaker just like the one beside it. Those are singles, and this is a double. So it has two wires going into that breaker.
So here with three-phase, you use the same kind of circuit breakers. The two-phase circuit breakers will work here.
Oh, absolutely.
Which is kind of mind-blowing. But then they actually go like one phase, 2, 3, 2, 3, 1, 2, 3, 1, and so if you put in a single breaker, the way 208 works is you get your 120 volts out of there.
Yes.
And then you put two of them in, you get your 208 volts.
Yes. But if you put three of them in, you still get 208. You just get three-phase power for motors.
So, and this is an example of a three-phase,
three-pole breaker.
So it's like three breakers kind of glued together, but but you can get your three-phase power out of here.
And that's the breaker that used to power the compressor that you had in the back.
Right.
And it was the only three-phase needed out of this panel.
Yeah. So we have wired a bunch of two-phase powers for our 208 volt.
Yeah.
And then a bunch of single breakers for our 115. It's interesting that it's 115, but it's 208, and it's just the way that the circuit works.
There's a math calculation to it, so that you multiply it by the square root of 3 instead of doubling it. Because you now have 3 phases, and the way that the sine waves are working, your maximum voltage is going to be
Right.
120 times the square root of 3, which will bring you to 208, instead of
Yeah.
120 times 2, which is 240.
Yeah. Yeah. I'm used to seeing the square root of 2 for two-phase stuff and building power supplies.
Yeah.
What we did was we had a bunch of pieces of paper with, I colored them red and green. We'll find some. And one was for 115 volt circuits and one was for 208 volt circuits. And then the other thing we did was on each one we wrote what piece of equipment it was and what amperage that piece of equipment was.
And whether it was dedicated or not, or if because you're only one person in the shop,
Yeah.
if you can have multiple machines on one circuit because you're only going to
Yeah.
be using one machine.
What we looked at for a dedicated circuit was a machine that would be going at the same time as other machines. So like the dust collection system, like the CNC that we're building here, the plasma cutter, any kind of machine that could be running while other machines are going. We mark those as dedicated,
Yes.
but a lot of the other machines, like we're not going to be running the 2 table saws at the same time.
Exactly.
And so it's just like home outlets. You don't have one circuit going to each outlet in a house. You have multiple outlets together. So we just marked them, all that, and then you went around and to all these pieces of paper, wired it in. And then what a nice thing that you did is when you took that piece of paper off of there, that's how we knew that that was live now.
Yep. It was ready to go, and you could start plugging stuff in.
Which is important. A lot of the communication, like you're working, you know, we may not be here when you're doing things, but those kind of things where you're basically saying, this is live now, and it's a good way of communicating, just to be safe. One other thing that you've done, I guess is put in a lot of the, what do they call them,
Kellum grips.
Kellum grips, or also known as horsecocks.
Yeah, they're there to hold up that extension port so that there's no stress at the connector pulling it out of the box.
Yeah.
And same thing at the bottom. There's one at the box also for one, again, as a stress relief situation, so you cannot pull that connector out of the box as well.
And this was a really nice solution for us. So we have it's almost like a rainforest of vines hanging down, but each one is a circuit, and some of them are 110 or 115, some are 208, and different currents, different types of outlets there. So they're close to where we know we want the machines, but it allows us to move machines around, and it also allows us, if we pull something back and we need to go through with a forklift, we don't have a permanent thing coming down from the
Swing them
ceiling.
off to the side.
Yeah, so it was a really, really neat idea. One of the things that Nelson has brought to us is I would go and talk to him and say, you know, I want to wire these lights in this way. Can you think of a good way of doing that? And you'd think about it in 2 minutes and you'd come up with a completely different way of doing it that I hadn't thought of that was the right solution. And it's your years of experience that kind of comes into this, you know.
You have to meet your electrical code. There is a safety requirement for stuff. You can't just decide to do it this way because if you feel like it. So as long as you meet that safety requirement, you just find a way to do it.
It's also nice to have you here. I ask you questions, you know, well what about can I wire an outlet this way or that way? And it's just nice to have the experience that you bring to.
Well, it's the experience, it's the knowledge, because you have a pretty good idea what's going on, but you don't know every product that's out there.
Yeah.
By doing this for a living, I'm exposed to a lot more than you are. So.
Yeah, and you've seen things done right and wrong, and you also you can do something like one thing I was asking about was you have outlets that have a little hole that you can just jam the wire in the back, and that's pretty convenient for wiring things up. But you've seen, you know, over years those things stop working, especially in a shop like this where you might have high startup currents on something.
Yeah. And for the second it takes, just wrap it around the screw. It'll be good forever.
Yeah, yeah. And it's also nice you can undo it if you want to and swap it out. Whereas with the other, you're trying to pull the wire out, putting stress on everything,
and
nicking the wire.
Once you pull it out, then there's no way you're going to put it back in that hole because it's not going to hold it there properly anymore.
Yeah. So this reminds me of those finger torture.
Chinese finger traps?
Yeah, yeah,
It works like one too. Don't put your finger in there and try to yank it out.
it will.
It will trap it.
So this means that this won't bend sharply as it comes into the box, right?
It won't bend sharply, and you can't physically
pull it out,
Pull
right.
it out of the box.
Yeah,
Because one of the things that happens with stress is the wire starts slowly working its way out of the connector,
yeah,
and then you have the conductor sticking out of the box.
okay. So as this goes in, what is actually grabbing around the wire as it goes in there?
This is grabbing around the coat.
Yeah.
There's nothing actually grabbing around the wire. You have a little
Sort of like,
grommet in there to prevent dust and water
Okay.
from coming in, but basically it's the grip itself that's holding the wire in position.
okay. And then at the top, it's similar. You have one of these things holding it, but then this part is actually through an eye
Yeah,
bolt
it's got a loop.
into the ceiling, right?
Exactly.
And that's the stress. And then the wire comes out through that and into your electrical
Into the
box,
junction
just sort of a normal
Because
connection.
that
there.
allows me to leave a loop at the ceiling so
Yeah.
that I know positively there's no pressure on that connector up the top.
Yeah. We're in the welding area of the shop, so we have, just happens to be, we're here because we have one of every kind. But we have the welding outlets. These are 30 amp circuits.
Yeah.
And, but most of our welders have a 50 amp plug, so we've had to make some adapters for that, which is kind of weird.
But you look at the intake current on your plugs and they're all under 30 amps.
Yeah.
So
Yeah. And this is every place I've been at with a welding outlet, it's this. But for some weird reason, the welders don't come with those kind of plugs. And we have,
and these you are your standard 15 amps and
Yeah.
the 208 volt plug.
so these ones we call snake eyes ones that have sideways ones. They are,
That's the differentiate between the 208 volts
Yeah.
and the 120. You cannot physically put a regular plug in these.
right.
With the
So this is like 15 amp or 15 or 20 amp,
15 amp.
15 amp, 208 volt.
Yeah.
And then normal 15 amp.
Yep.
Well, and some of these you've actually, when it's a dedicated circuit, you've actually taken and made these separate outlets, kind of like a kitchen outlet.
It's like a kitchen outlet. You have one position back there where you have two machines that both require a dedicated circuit. So rather than running down two extension cords, I brought two circuits down
Right.
into
That's nice.
the one plug.
And you can see, if our first thing that we were thinking is we'd have to bring down some metal, what do you call that?
Channels.
Yeah, some channels, sort of physically attach them to the floor and to the ceiling.
Yeah.
And then mount these things on it. But with this, we can pull something aside, come through with a forklift, and it's still code, it's still
Yeah.
a solid way of doing things. And these are some examples of the things where we have like a 20 amp 208 volt outlet. So the red and the green for 115 volts.
And your welding plugs.
Yeah. So we had these all over the shop so that Nelson had something to sort of follow.
As a matter of fact, we can take them all off now.
Yeah, I guess we can, yeah, since they're all working. Yeah, as you look around, you just see outlets all along. It's great. It's we've really tried to think ahead so that we can reposition things. We have welding outlets. This area of the shop is for welding, so we've got welding outlets all around, and so we can plug in without huge long extension cords, going everywhere. It's a lot safer. So thanks very much, Nelson. Thanks for coming in and spending this time to talk to us. And it's been really, really great having you here.
It was my pleasure.
wiring up the
It
shop.
actually looks kind of neat, and
Yeah.
it was interesting doing the
So
work.
nice. You're a great guy.
Kind of
Thanks.
looking forward to seeing the place open.
I'm here today with Norton, who's an electrician from Broder Electric.
It's Nelson, by the way.
Sorry, is it? Have I been calling you Norton all along?
I've been ignoring the
Okay.
Norton part.
All
but
right,
now we're
sorry.
okay.
Okay. Sorry. Hi, I'm here today with Nelson from Broder Electric.